Hey everybody, Mr. Covey here, and I know it's the end of the year, and with this e-learning, you guys are probably losing a little bit of your motivation, but I'm telling you right now, the thing we're learning today is super important for calculus. Most of you guys are taking a calculus class. The ideas we're talking about today are like extremely important. They're like the foundational ideas. So try and give it your all. Stick with me here. It's going to be a lot of stuff, but like you can do it. Okay. So we're going to talk about something called the difference quotient. But before we do that, in order to help us understand that, we're going to think about the difference between average and instantaneous speed. Okay, so we're going to look at some word problems. We're going to think about speed. It's going to help us understand this difference quotient thing. Okay. So first problem we're going to look at. Gianna was racing with Kristen and recorded her distance from the starting point for the duration of the race. And we got a graph of it. Okay. What were they racing for? I don't know. Maybe they were like, there was a new calculator coming out and they're like racing to try and get it or something. Normal things. Okay. So you got a graph here. Got time on the x-axis and you got distance in meters on the y-axis. And you know, as time went on, they were farther and farther. And this is Gianna's graph. Cool. Okay. So the question we're going to answer is, what was Gianna's average speed for the first 5 minutes of the race? Okay, so if you're thinking about speed, and maybe it's been a while since you've thought about speed, you know how to find an average speed. Okay, let's say like, hey, I drove 200 miles in 2 hours. What was my speed? 200 divided by 2, it'd be 100 miles per hour. Okay, so you might be thinking, remembering like distance equals rate times time. In other words, distance over time equals rate, right? Like if you go 50 miles in 5 hours, you went 10 miles an hour. You guys know that. So we're going to use that idea. We're going to divide distance over time to give us a rate. So to find her average speed for the first 5 minutes, we're going to take a time 0. She had gone 0 distance, and we're going to take about 5 minutes into the race. Well, 5 minutes into the race, she'd gone 800 meters. And 5 minutes had elapsed. So we're doing our distance divided by our time. We can type that in our calculators or just use our brain. My brain isn't working as well as it used to be since this e-learning stuff, so I use my calculator. It's kind of sad. Come on, Mr. Covey. Anyway, we get 160, and our units here, because we're talking about a speed, are meters per minute. So that was her speed for the first 5 minutes of the race. Okay. Why don't you go pause real quick and you do B. Okay. So I hope for B, that wasn't too bad. She went 900 meters at the 9 minutes, so she went. Her speed was 100 meters per minute. Okay. Cool. Okay. Next question's a little different. Saying, what's her average speed between 9 minutes and 14 minutes into the race? Okay, so her average speed, like from the 9 minute mark to the 14 minute mark. Okay, and our 14 minute mark is all the way over here. So we're kind of like looking at these 2 points. We can find the speed, the speed between those two, the average speed. So we're still doing distance over time. How much distance is she traveling? 400 meters. How much time is she traveling? Well, it's 5 minutes. I'm going to do a little calculation. I'm going to write it out like this. This should be jogging a little bit of a memory here. 1,300 minus, 900 would tell us the total distance that she traveled. So she traveled 400 meters, and then it was 14 minutes minus 9 minutes over 5, and so it would be 80 meters per minute. Okay. Why don't you pause and do D real quick? Okay, 92.85 is what I got meters per minute. I hope right now you're thinking like, what are we doing? This seems kind of simple. I hope that when you're seeing a calculation like this, you're thinking, oh, wait, I know what we're doing. We're doing slope. I hope that you're thinking about slope. Okay, and we'll talk more about that. But anyway, the interesting question that's going to be the new question, that's the calculus question, okay, is E. And this is where it starts to get interesting. What is her speed exactly 3 minutes into the race, into the game? Okay, this is where it gets a little confusing because of this word exactly. I'm not asking for her average speed for the first 3 minutes. We could do that. We just do it the same way we did all these. I want to know her exact speed 3 minutes into the race. It's a weird question, but if you think about it, like the way you calculate speed is you do like a distance over time. But if you think about it like at an instance, like it doesn't really make any sense. Okay. Because if you think about this calculation, 700 divided by 3, that's her average speed for the first 3 minutes. But the problem is, like, if you look at this graph, like, she's going faster here. Like, she's going real fast. And then she slows down when she gets to 3 minutes. So, like, she's probably going slower than 233.3 meters per minute then. So this is kind of a bad guess. This is a confusing question. This is a core, complicated question that we're going to come back to, but I want to get your brain thinking about that now. Maybe you have some ideas, maybe you have no idea. That's cool. We're going to come back to it. Don't worry. In general, though, how do you find average speed on a distance versus time graph? You do slope. y2 minus y1 over x2 minus x1. Slope. Okay, this should be familiar. If you look back here, we were doing slopes between points. We were doing y2 minus y1 over x2 minus x1. We were doing slopes. Slopes. The reason here, if it was for the first 9 minutes, then the starting distance was 0 and the starting time was 0, and that's why those ones look a little different. That one looks. Okay, but we were doing, okay? Cool. Okay. All right, now I want to shift our thinking. And I want to do a similar problem, but I want to think about calculating slope a slightly different way. Basically, like just a fancy formula for calculating slope called the difference quotient. Okay? It is called the difference quotient for a couple reasons. First, it's got the word quotient in it. What does quotient mean? Division. Good. It means division. So this formula is going to have division in it, which makes sense because slopes change in y over change in x. It has division in it. Okay, so our formula is still going to have division in it, and it's called the difference quotient. What does the word difference mean in math? It means subtraction. So it's going to have subtraction just like our normal slope formula. Okay, so this is just a fancy slope formula. It's going to help to understand this formula if you flip forward a couple pages in your notes and go to this picture here. Okay, so in this picture we have some graph, whatever. It's not a line. It's a curvy graph, and we're trying to find the slope between 2 points. And normally in our slope formula, we call this x1 and we call this x2, and we call this y1 and we call this y2. But we labeled these a little bit different here, and I want to talk about that, okay? So we're still calling the first x value, we're just calling it x now. And instead of calling the y value associated with that y, we're using function notation. So we're saying like, hey, you got an x, and then the y value is f of that x value, f of x, okay? The weird part is, instead of thinking about another x value here and just calling it like x2, like the other x value that you're finding the slope between these 2 points, we're calling it x plus h. And so what the h is here is how far over you have to move to get to the new x value. Okay, so that distance there is h. So you got one x value, and then you got another one that's that other x value, but moved h over. Okay, so like let's say x was 6, and you wanted to move over 3, then the other x value would be 6 plus 3 would be 9. Okay. So once you have this other x value, how do you find the y value at that x value? Well, you plug it into the function. You do f of that new x value, which is x plus h. Okay. So you have 2 points here. You have x f of x, and then the other point is x plus h, f of x plus h. Those are the points, the x and the y coordinates. Okay, x's, y's. How are you going to find the slope between those? You're going to do change in y over change in x. You're going to subtract the y's and divide it by what you get when you subtract the x's. Okay, you jump back to our other sheet now. We're going to write that down. Something's going to happen here. So we're going to do change in the y's, y2 minus y1, over change in the x's, x2 minus x1. Okay. And one thing happens here, the top stays like that, f of x plus h minus f of x, all divided by, here you got x plus h minus x, let's just h. Okay. This is the difference quotient, okay? The confusing part is the h. And what you should think about the h as being is how far apart the x's are. The distance between x values. What's the x here? It's the first x value. Oops, sorry. And again, what are we doing? Slope. I'm just showing you a different way to calculate slope. Right now, your thought should be, I already know how to calculate slope. Why do I need a new way to calculate slope? Great question. It's going to help us with calculus, I promise. But right now, it's not like there's no reason we're doing this new way. I'm just like showing you a new way. Okay. Now I want to do a very similar problem to the one we did before, but with this new slope formula, this difference quotient formula. Okay, really similar problem though. Hey, Emma runs a very consistent 5K with the cross-country team. She's blah, 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 blah. Distance formula. So instead of giving you a graph here though, I'm giving you like a formula that is her distance and x's time. Okay, this is the exact same situation. I could totally draw a graph and call this x, and this would be time, and this would be the y values, d of x, and this would be distance, and I would graph this, and it'd look just like the one with Gianna on the last problem. Only I'm not going to graph it. I'm going to do this just like understanding what's going on. Okay, so I'm not going to rely on a graph here. Okay. Same idea though, saying distance versus time graph. Okay, so this first question is just making sure we understand what's going on. How long does it take her to run 5 kilometers? Okay, well, they're not asking me for a speed here. This has nothing to do with speed. I'm just making sure you understand what's going on. Oh, so they're giving me a distance and they're asking me a time. I'm going to plug in 5 for the distance and I'm going to solve for the time. This is just old school math. You know what I mean? Like, oh, okay, just like old school solve that equation. It's quadratic. You know what I do? I'm going to throw out my calculator. How do you solve an equation on your calculator? You guys remember this. You just plug in this for y1 and this for y2 and figure out where they intersect. This is just old stuff. I just want you to remember this, okay? So, hey, how do I solve this equation? I could like move it all over and do quadratic formula or something, but I'm not even feeling that. I'm just going to do something calculator real quick. Type in the 2 equations. Oops, sorry. I'm going to graph them and I'm going to figure out where they intersect. Okay. Here's my calculator's in a weird window. Oh no, actually, never mind. I can see it. Okay. Remember, I'm trying to find a time where they intersect. I'm trying to how long it takes it to run 5K. So I'm trying to find that thing. Cool. I'm just gonna go second calc. Well, I should probably show you what it looks like on your window. Maybe if you hit zoom 6, you can't quite. Can you see it? Oh, cool. Perfect. Okay. So then, oh no, we gotta make it wider. So hit your window. You need to make the x values a little bigger. That x max and x min. And keep in mind, x is time, so I don't really care about negative time. I'm going to toss that x max up to 25. See if I can see that point of intersection now. How long it took her to go? 5 kilometers? Yep, cool. Second, calc, intersect. Okay. This has nothing to do with the new stuff we're doing now. I just want you to remember this. This is not new. It's just like how do you find out, solve an equation in your calculator to figure out where they intersect. 15.08. Let's say 0.79, actually. Okay, so that's how many minutes it took her to run 5 kilometers. Nothing with speed there. I just wanted you to remember that old stuff. Okay. All right. Now we want to know speed. Okay. What was her average speed over the course of the entire race? Okay. Well, it was a 5K race. So, so she ran this far and this long. Okay, but I want to do this with this difference quotient. Okay, so I'm finding speed, so I'm going to be doing a slope calculation, but I want to do it with this difference quotient. My x values are time, and my f of x values are distances. What is her starting time if I'm doing her average speed for the whole race? Well, the starting time is 0. How far apart am I taking, are my two times? Excuse me. How much time goes on before I take my other distance measurement? In other words, how much is the total time that's elapsed from here to the ending time? 15.074. Okay. So once you establish your starting x value and then how far to get to the other x value, to the end of the race, then you can use your difference quotient to find your speed. Okay, so again, here's what our difference quotient is, right here. Only I'm not going to do f of x plus h minus f of x over h. I'm going to do d of x plus h minus d of x over h. Okay, so I'm going to do d of x plus h all over h. Again, all I'm doing is calculating slope. I'm just using this new fancy way. Okay, well, that's d of 15.074 divided by 15.074. Oh, sorry, that's a 9. Okay. What is d of 15.079? How far had she gone in 15.079 minutes? Well, she'd gone the 5 kilometers in 15.079 minutes. Type it in our calculator. Sorry, give me a second. We get her average speed, 0.332 kilometers per minute. Okay. Again, I just want to focus on using this new thing called the difference quotient. Okay, so let's do it again. What was her average speed over the course of the first 5 minutes? Okay, well, the initial time that I'm measuring the slope from is 0. How far apart are the two times? Well, the second time is 5, so they're 5 apart since the first one was 0. And now I'm going to use the difference quotient. I'm going to do d of x plus h minus d of, oh, I forgot to do that up here. I should change that. Just so you know, I forgot to do minus d of x here. Excuse me. But what's distance at time 0? It was 0. So I didn't change the answer, but I should do that. My bad. I didn't include that there. Okay, so d of x plus h minus d of x all over h. Okay, so here is my slope calculation using the difference quotient. Okay, you with me, guys? So I'm going to simplify. I got d of 5 minus d of 0 all over 5. Again, this d function is telling you the distance after a certain amount of time. How far had she gone after 0 minutes? Well, 0. You could plug that into the function and see. How far had she gone after 5 minutes? Well, I'm going to plug 5 into my function. Okay, grab your calculator. Plug in 5. What's 5 squared? It's 25. Even I know that. Okay, 0.65. Type in my calculator, 0.65 divided by 5 is 0.13 kilometers per minute. Okay, so that was her average speed for the first 5 minutes of the race. Okay, using this difference quotient. Okay, I want to keep going with this. What was her average speed over the course of the second 5 minutes of the race. So not those first 5 minutes, the second 5 minutes, from time 5 to time 10. Okay, so here's where we got a little confusing. We're still finding speed, we're still doing slope. We're gonna do it with the difference quotient. What's the initial time that we're starting to measure the speed at? Well, it's 5 minutes in. How far apart are the two times? Well, 5 minutes to 10 minutes. The times themselves are 5 minutes apart. Note that this h isn't the second time. Go back to this picture. That h is not the second x value. It's how far apart the x values are. So in this case, it's how far apart the times are. How far apart are 5 and 10? They're 5 apart. Now I'm going to use my difference quotient. D of x plus h minus d of x all over h. Okay, and I'm going to calculate this. It's d of 10 minus d of 5 divided by 5. So now I have to go to my function and plug in 10 to figure out what d of 10 is. Same with 5. Okay, so for d of 10, I got 2.3. For d of 5, we already did that. I got 0.65. I'm going to subtract those and divide by 5. And I got 0.33. And again, I'm finding a speed, so it's kilometers per minute. So that was our average speed. Oops, sorry. For the second 5 minutes of the race. Okay. All right. I'm just going to tell you the setup for E, and then I want you guys to calculate it. Okay. Okay. So it's your average speed between 3 minutes and 4 minutes into a race. So what's the first time? 3 minutes. Again, the h is how far apart the times are. How far apart are these times? 1. Okay. Now I can do my difference quotient. D of x plus h minus d of x all over h. Okay, go ahead and calculate that. Okay, should have gotten 0.17, kilometers per minute. Okay, all right. So then back to this confusing question. Okay, how would you figure out her speed at 2 minutes, exactly at 2 minutes? Okay, I want you to think about this. I want you to pause and I want you to give it a try. In other words, what x value and what h value would you want to use to figure out her speed at 2 minutes? Not for the first 5 minutes or 2 minutes, exactly at 2 minutes. Okay, I know this is weird because I can't actually ask you guys, but here are some good answers I've gotten in the past. If you want to know her speed at 2 minutes, well, the first x value you should use needs to be close to 2 minutes. But the second one, you want to not be that far away. If it's really far away, what happens is there's a lot of time for your speed to change. And so you could get an inaccurate estimate of your speed at 2 minutes. Okay, so how far apart do you want the two x values? How far do you want the second x value to be away? Really close, like 0.1 away. Or even better, like 0.01 away. You want that second x value to be really, really close. Okay. If you're confused about this, the difference, like how this is any different than the other ones, think about like, I'll do one quick example, just a normal thing. Think about like when you get pulled over for speeding, which you would never do. But think about what the cop is saying when he pulls you over. He's saying that at a point in time when he points your radar gun at, or when he pointed the radar gun at your car, he's telling you like you were speeding because you were going 60 miles an hour. But how is he figuring out that you're going 60 miles an hour like at a single point in time? Because speed is distance over time. So how is he figuring that out? This is actually how it works, and it's going to help you understand how this calculus thing works. How a radar gun works is he's measuring your distance, how far away you are from him, and then he's measuring your distance again like a millisecond later. So he's actually not finding your average speed, or excuse me, your instantaneous speed. He's finding your average speed. But how big is the interval? It's like a millisecond. So he's saying like, oh, well, in 1 millisecond, you went 2 feet. So you were going 60 miles an hour. That's what a radar gun does. It's finding your average speed, but it's finding your average speed over a really small interval and then it's pretending like that's your actual speed at a single point in time. Those are different things, though. Okay. If you're still confused about this, do more practice with it. Don't worry. Okay. But big idea is average speed. Okay. Here's the big ideas, and then we can wrap this up. Average speed is distance over time. You do distance over time between 2 points. Okay, and we're using the difference quotient to do it. It's slope. It's not that bad. Okay, how do you find average speed? You do slope between 2 points. Not bad. Okay. Now, this idea of determining your speed at a single point in time is weird because you don't have 2 points. You're not saying like what was your speed between this point in time and this point in time. You want to know your speed like at a single point, which is confusing. Okay. It's still slope because it's still speed, but you don't have 2 points to work with. One idea, which is the idea we're going to use, is this. If I was going to summarize this idea, it's get the 2 points to be very close together. And we'll come back to that idea. But because maybe we can use this average speed, this difference quotient idea that we were doing, to help us calculate instantaneous speed, which right now we don't have a way to calculate this. Okay, we know how to do average speed, but we don't know how to do instantaneous. We're going to use the average speed idea to help us with instantaneous speed. Okay, all right. So if you jump over to this page, I'd like you to do some practice now with the difference quotient. Here is our difference quotient formula. Remember, it's just a fancy way to calculate slope. We got this picture here. Here's not word problems, just good old-fashioned functions. Here's the first x value. Here's the second x value. I want you to use the difference quotient to calculate the slope. I'll help you set up this first one, and then I want you to do a little practice with it. And then there's a second follow-up video that's shorter. Okay? So, all right, I'm trying to find the slope between this x value and this x value. Okay? Remember, for difference quotient, you need to figure out what the x is and what the h is. Remember, h is how far apart are the x values. How far apart are these x values? They are 4 apart. So how would I find the slope between these x values of this function? I do the difference quotient. F of x plus h minus f of x all over h. So it'd be f of 5 minus f of 1 over 4. How do you find f of 5? You plug 5 in here. 5 squared plus 5 times 5 minus 4, you get 46. How do you find f of 1? You plug in 1. 1 squared plus 6. Boom. Boom. It's 11. Okay? That's me using the difference quotient to find the slope between these 2 points. Remember, it's all about figuring out what the x plus h is. All right, do a little practice here. Check your answers. There's an answer key up for this, and then the second video for you to watch. Thanks for watching, guys.